Hey there and welcome back to the Codnicals channel for a brand new video. Let's suppose that you are right now working on a pull request. Maybe you create a new application or your team is working on a new application and a new controller needs to be set up, and this is the controller. So this is what the pull request would look like. Just as a regular controller, we have this iLogger, we have this iMapper, the iMediator. We use, of course, dependency injection to assign the instances to the fields, to the private read-only fields that we have here. And then we have this method, like here we want to create a weather forecast. And that's kind of like the structure that we would see usually in most of the controllers or most of the controller actions out there. Now we validate the model, we look into the headers of the request because we want to get a value from there, we do our job. We also use the try catch because we want to catch exceptions if we have any, then we do some logging, and last but not least, we return the result, which is a created. The question is, what would you do with the pull request? Would it be the default, looks good for me and everything would be completed? Or would you have some suggestions for improvements? Stay tuned because just in a few seconds, I will let you know how I would think about such a pull request and such a code and how we could improve that. To start off, I would say that this code is, well, it's not terrible and it's also not great. Theoretically, we could actually go along with that because there is not really much happening here in this controller action, and I guess we could live with that. However, the problem is that in regular applications, always you start from something that's kind of like quite simple, but usually it gets added and added and added, and maybe other methods or other controller actions, they will require some more logic or some more things or some more wiring to do, and you would still do everything in the action because that's how well you set up or how it was done in the first place when the very first action was created. And that's why I would always try to actually see if we can improve things in the controllers that we have, because keeping clean controllers is one of the most important things in our ASP.NET Core applications. It makes our applications so much more readable and so much more easier to maintain, and that's of course a good thing. Now, the problem with this controller is that it has a lot of things that kind of like clutter the controller itself. For instance, in each controller, basically in this application, we would have to inject at least the logger, the mapper, and the iMediator, because these are the tools with which we work. And it's obviously that we need to inject them and use them, but we would repeat this in really every controller. And that's for me a sign that, hey, maybe we could look into something more smart than that or smarter than that and see exactly if we could do something about that. But then again, if we go a little bit further in this controller action, here we have some steps that we actually perform, and those steps would also in a certain way be very repetitive in certain scenarios, like for instance, validation of the model. Basically, in each controller action that takes in a model or that comes with a request body, you have to validate that body because you need to make sure that all the information in that body is according to, well, your application logic and that it actually makes sense. So this is a very important part. Then the other thing that we do here is we check the HTTP context for a certain header. Now, this is also something that we have fairly often to do because we need to look into the HTTP context for different type of stuff, maybe headers, but maybe query params or other type of information. So working with the HTTP context is something that we encounter fairly often, I would say, in our ASP.NET Core application. And that becomes also kind of like a little bit repetitive. So is there any way in which you could do things better than we have them now? And then what we do is actually the logic itself. First of all, we just map the body to our create, or well, we map the body that we get here because it's a DTO. We map it directly to a domain model, which is the weather forecast. Then we create a command for this create forecast because we want to create a forecast, and we just send this to the mediator. Of course, in a try catch block, because if we have an exception, well, we want to log the exception, but we also want to return status code 500 because we encountered an internal server error, and that's what we usually want to return in these cases. And once again, putting everything or all the logic or all the mediator stuff in try catch blocks in each controller action kind of like doesn't really look very nice to me. So we would also have to look into ways in which we could refactor that and make everything looks cleaner than that. And then this logging part, this is also kind of like, well, I would say a scenario that you encounter fairly often, where you want just to log something, where logging is important, and in real applications or production applications, you usually log stuff. Now, the thing is that this also clutters my controller action. We'll have to look into ways or options that we could use in order to actually move all this logging part away from here, and let's see if this is actually possible and how. And then, of course, we just return the result and everything is okay. Cool. Now, before we go into the refactoring of this controller and of this controller action, I just want to state, obviously, this example is just for a demo purpose, because my goal here was to create actually a controller or a controller action that would mimic the general structure of maybe 90% of the controller actions out there. And this type of steps are usually present in most of the controller actions. Obviously, you would have maybe additional steps or some other kind of logic in the controller, which might be good or bad, of course. But this is a structure that's very common, and that's why I just want to focus on that, because my goal in this video is just to actually pinpoint very few and key steps that we can always look to or ask ourselves if we can move parts of our code into different other parts of the application. So what I want to actually create in this video is not really to give you a solution, but really to kind of like make you aware about the thought process that you would need to go through with all your controllers and controller actions. Cool. So let's take all these challenges, or well, spaces or places where we told that there might be room for improvement, and let's see how we can improve that. Now, the first thing that we have said is kind of like, this is bothering me a little bit, because in every controller, in each and every controller, I would have to actually add these private fields, because I will always use a logger, I will always use a mapper, and I will always use a mediator. So of course, I will have them in all controllers. This comes in, of course, we want to inject instances of those types in our constructor and assign them to a private field. So by default, each controller in my application would have at least these 3 services injected, but regular or usually I would probably have more. So is there a way in which I can declutter a little bit my controller right now, or the fields or the constructor of the controller, so that I don't really need to inject every time all the services that I know beforehand I will need in all controllers? And here, this is the very first step that I would propose in this thought process on how we can improve the quality of our controllers and controller actions, is to use a base controller and move everything, or always ask yourself if certain parts of what you have in your controller or in your controller action can be moved to the base or in the base controller or not. Now, in order to do this, I already have created here a very basic base controller, and the base controller that would help me with these services would look something like this. The idea here is that I still want to have these private fields with iLogger, iMapper, and iMediator, because what I do here is actually, well, I need these private fields because what I do with the properties, because I expose some protected properties with the logger, with the mediator, and with the mapper. And the idea is that if I wouldn't use those fields, it would mean that every time somebody would ask for a logger or for the mediator or for the mapper, I would have to get the required service from the HTTP context. And I want to avoid that. I just want to get the service only once, because we are here in a scope of a request, and we are talking about scoped services mostly here that are of great importance. So the idea is that I would like to resolve them only once, and then if anybody else requests one of these properties, we already have it in the field. And that's why I use, or I prefer to use, these private fields, but also expose some protected properties on this base controller class, and use the HTTP context, because in the HTTP context you have this request services collection in which, or through which, you can actually inject or get or resolve required services. So in first place, we get the required service for the iLogger, we then get the required service of type iMediator, and then we get the required service of type IMapper. And then, of course, these properties are available in all controllers that inherit our base controller. And here there is one other very, very important stuff. This base controller, we have made it as a generic class. And the reason why we did this is due to the iLogger, because the iLogger needs always to have also, or it should have at least, because we can use iLogger without it, but it should have a generic type parameter that would specify the name of the logger, or actually where exactly this logger does the logging. And that's why we use this T. And we say that, okay, our base controller inherits from the ASP.NET Core controller base, but we place a type constraint on T, and we say that T needs to inherit the base controller, so our class of type T. And this kind of like solves the problems with the logger, because right now we can have a type logger here and we can use it. And how this looks in the controller is, of course, that instead of inheriting the controller base, we would inherit our base controller, but of type weather forecast controller. Where is it? Here. That should be it. And right now we actually should be good to go on. And what we can do here theoretically is we can just simply get rid of all the stuff that we have here. So just get rid of everything. We can also clean up our constructor. We don't need this anymore. So everything is okay. Now, the only thing that we need to do is, hey, we just need to replace here these names. Like this would be the mapper. This is the protected property that we have on the base controller. This would be the mediator, also a protected property that we have on the base controller. That would be the logger, the other protected property that we have on the controller. And of course, I also have to type correctly. And then once again, this logger, okay. Now let's just use the logger as a property that we have on our base controller. And that's it. Already, actually, our controller looks nicer because we can, in this case, since we don't resolve any other service, we can just simply get rid of the entire constructor here. And suddenly, my controller already looks better because all the things that I know I will need in all controllers, I have moved over in the base controller. And then I have just reused here some of the properties of some of the protected properties that I have exposed on the base controller, and that's kind of like it. So the first step in this thought process is always look and think if you can move stuff into your base controller. Now, of course, this doesn't mean that you have to move everything there. You just have to also do a little bit of critical thinking and try to ask yourself, it makes sense to move a certain piece of code from your controller or from your controller action to the base controller, because in some cases it probably doesn't make sense. And for instance, if we want to look at this, like if model state is valid, that's a line of code that we would have in each controller action that would kind of like take in or would work with the request body. We will have to validate that. And of course, moving this validation in the controller base might not be the best idea, because not all controllers probably will have to do validation, and not all actions in the controllers will have to do validations. So maybe we should think here about something else, and that's why we will introduce this concept of filters. Filters are very powerful in ASP.NET Core, but unfortunately I think they are also underrated and also underused. I have created a dedicated video, especially or dedicated only to filters in ASP.NET Core, where I discuss this topic in depth about what filters are, how do we use them, what types of filter do we have. So if you want to get more information on how filters work and what filters are in ASP.NET Core, please go to that video. You will find a link to that video in the description of this one and on a card here on the corner up right. But let's say, as a general definition of a filter in ASP.NET Core is that it is a way that allows us to execute some code right before and or right after a controller action is executed. And that would actually make a primary target for our refactoring, because we could just move model validation in a filter and declutter our controller action. To do this, we will have to create a filter first, and we'll do this in the filters folder that I have created previously. And here we just need to add a new class, and we'll call this very simple forecast validation attribute. And we'll call this with attribute as a suffix because we want to make this an attribute. This is one way in which we could use filters, and this would also mean that we would have to inherit the attribute class, and then we would have to make it a filter. And I would use an action filter. The action filters have both a non-async and an async and a non-async implementation, and that one is exposed through dedicated interfaces. I want to use an async action filter that would allow me also to maybe use some async stuff here if needed. However, I don't think it will be the case right now, but we will still use it this way. Now, the idea is that what we can do here is we can simply move that validation logic that we had previously in our filter. Now, the filter has this context, which is the action executing context. And on this context, we actually have access to the model state, just like we have it in the controller. Now, the only thing is that we cannot simply return a bad request. What we need to do in a filter for everything to actually work is we would have to set the result on the context, and this would kind of like circuit the entire filter pipeline and will return automatically the result. And the result would be equal to new bad request result. That's what we want to return. And that's it. That's all we need to do. And we have moved right now this model validation, or to be more specific, this forecast validation, into a filter. Now, the way that we actually use it is we can go back to the controller and we can simply decorate the controller with the forecast validation. And that's it. Right now, when we make a request, since we have decorated this controller action with this filter, it means that it will automatically go and execute our code. So it will check the model state. If the model state is not valid, then, well, we will already create a result of type bad request and we will return that. This means that the code or the execution of the program will not even arrive in the action anymore, which is actually a good thing, because if we find some problems down the way with the request that comes in, we can just already create a response and we don't need to really execute code that doesn't really need to be executed. So that's kind of like very, very nice. So we have solved this problem with the model validation. Let's move then to the next step. So we have here this stuff that we have on the HTTP context, in which in our case, we just want to check for a certain header and get the value for that specific header. And here, of course, we don't really have the option to move this into a filter because it's not really tied to a certain request or an action that we want to perform before the request, because we would have to then kind of like make this information somehow available to our controller action. So that is not possible. But then there is another very important thing that we should always try to keep in mind when we look at our code is, okay, can we extract to a base controller? If not, okay, can we extract or place something in a filter like we did earlier? Okay, we cannot do this with the HTTP context. Then the next thing is, can we create an extension method, for instance, on the HTTP context that would implement exactly the functionality that I need and gets me the results or the values that I need? And in that case, it would be easy because I would just use the HTTP context and call that extension method that I have created. To do this, we will go over to our extensions folder that I have already created previously, and we will add here a new class, and we will call this class HTTP context extensions, because that's what we actually want to do in this class, create extension methods for the HTTP context, and that would be a static class. And of course, we need to create here a static method that would return a string, because that's what's important for me right now. I want to get back a string that kind of like represents the information that I need from the header. And let's say get the header info, and it would be on this HTTP context.context. And then, of course, I will have the implementation of this method. And I can go back to the controller and actually let's take all this information that we have here. And we have, let's say, Control X, and let's go back to this one. And we have these string values. Okay, we add everything that we need. Here we have the context that is already here on the disk. So we have context request headers, try get value, summary, and I would like to out to the header info. And then what I would like to do, for instance, here is I will return header info dot to string, of course, and that would be it. Now I can go back to my controller and I can use, for instance, okay, I do here the mapping, but then I want to have var info equals, and I can say http context dot get header info. So exactly what we had previously. And then what we do here in this command, instead of providing this one, I would just provide the information that I got from the extension method. And once again, we are one step further. We have actually eliminated something from our controller action, and we have moved it this time to an extension method that kind of like will do the trick. And always when we need to get this type of information from the header, we can just get this header info. Now, of course, you can get a lot more fancy with this extension method, because you can potentially also say, okay, just to make it like if you want to extract information from any type of header, for instance, let's say just provide me also a key, like provide me a key for a header in which I have to look and check exactly if, well, we have something there. And in this case, we can make it like this. We can just provide a key here. And then in the controller, the only thing that we need to do here is we need to provide the key. So this is the key that we actually need. So that's it. We have our extension method. Then we create the command, and then we have this try catch block in which we actually place the mediator and the action of sending this command to the mediator and waiting for the result. Now, the thing is that kind of like this try catch construct will also clutter our controllers, and that's also something that we can actually try to address and make it look much cleaner. Now, the thing here is that in order to refactor this, we can once again take advantage of filters. Now, the reason why I know that is because there is a very specific filter, or a very specific type of filter in ASP.NET Core that's called an exception filter. And it's called an exception filter for a reason, because it's helpful, or it helps us to actually handle this part where we actually want to move the exception handling thing directly into a filter and declutter our controller and make it look nicer, easier to maintain, and easier to understand. So let's move to the next step and try to implement an exception filter and move all the exception handling stuff then in the filter itself. So let's go over once again back to our filters folder, and let's click here on add, and we click on class, and we call this exception handler. Now, when we think about this exception handling filter, there are a few things that we need to take into consideration. Now, the first thing that we need to look at is that when we catch the exception, we don't just return the status code 500, but we also log the error. So it means that our exception handling filter should also have the capability to actually also log the message or log something. This means that we would have a way, or we would need a way to actually inject the logger or logging or delogging infrastructure into our exception filter. And that in turn means that we will not use this exception handling filter as an attribute filter, but we will rather register it globally so that we have dependency injection attached to it. But there is also another reason why we want to register that filter globally, and that is, of course, we want to write our exception handler filter only once, and it should be applied to really all controllers and all actions. So no matter which one of them will throw an error, our exception handling filter will catch it and will do the needed stuff with that. So let's go back to the filter here, exception handler, and let's implement this filter. First of all, as we will not use this as an attribute, we will not inherit attribute. So instead, we will just implement iExceptionFilter. And this in turn will make us implement this method onException, which gives us an exception context that will contain some information about the action that has been executed, but it will also contain the exception and everything around the exception itself. And that information might prove useful when it comes to logging, at least, because we want to know what exactly happened. And then the next thing is, since we want to use the logger, we want to actually inject a logger directly here. So I'll have a private read-only iLogger, but in this case, it will be an iLogger of type exception handler. And yeah, let's call it logger as usual, and we'll have then a constructor. And in this constructor, we will then just have, okay, sorry, a lot of typos here. So iLogger of exception handler, and let's call this logger. Cool, we are okay with that. And now we just have to assign it logger equals logger. And just like that, we have the logging infrastructure into our exception filter. Now, the next step, of course, is that we need to go back to our controller. And what we need to do is we just want to actually execute the mediator. So we will have this outside this try and catch. We will move everything that we have here in the exception handler that we have just created. And this is what happens, or this method is then executed when an exception occurs. Now, of course, instead of this logger, we will use the logger that we have here. For the message, as said, we have the exception context, and on the exception context, we have, of course, the exception, and through the exception, we have actually access to this message. And like we have done also in the action filter for model validation, if things go wrong and we want to actually set a result, we need here a new status code result. And we want a status code result that returns 500, which would be the internal server error. And that would be all the logic that we had previously in the controller. So we have moved it into the filter. Now, the next thing that we can do is, of course, we can just go over here, and now we can actually remove everything because we don't need it anymore. Now, the really last thing that we need to do is, of course, we need to register this filter globally. And we do this in program.cs in builder services add controllers. This takes in actually a configuration object in which we can then further configure our controllers. And one of the configurations that we can do on the controllers is filters.add, and we specify type of in the type of the filter. And the type of my filter is the exception handler filter, and that would register my exception handling filter globally. Once again, that would mean that no matter what controller and what action gets executed, if there is an exception, this filter will actually kick in, and this onException method will execute. That will log the message, and then will generate, or that will generate a status code result. And yeah, that would be it. That would make everything actually good to go. Now, and we already see that our controller got, or our controller action got actually a lot cleaner than previously. Like, it's really, really straightforward what's actually happening here. Now, there is only one other thing that we still have remaining, which is this logger and log information. Now, here with this logging, of course, there are different types of strategies, and really here it depends a lot of the application and how do you want to do logging. Because if you want to do general logging on really each action that gets executed, then you can create also a global logging filter that would be of type action filter, in which you would log something before the action and in which you would log something after the action. However, if you want to keep this logging very, very, very specific to this exact action, then I don't think that we can actually directly do something with this logger log information. We could eventually just also create maybe an action filter, or kind of like a filter in which we would move this logging, but in that case, it would mean that we would need to create a filter that would responsible be only for one controller and one specific action, which would be this one. And that kind of like defeats a little bit the purpose of a filter, because filters you usually try to use when you can actually reuse that logic and apply it to different controllers or to different actions. Some of the filters, like we have seen with the global exception filters, you can even apply to all controllers. But the idea is that, well, kind of like what you put in the filter needs to be kind of a little bit reusable. So If you want to do very specific logging here that's action specific, then I'm afraid that, well, I think I would actually leave it like this, even though I would prefer a total different strategy, like I have mentioned just a few seconds ago, to maybe create a global logging filter that would log something before the action is executed and before and after the action is executed. And that would apply to really all the actions that we have in our application. It's something similar like ASP.NET Core does, for instance, when you do a request, because you have a lot of logging for that specific request. Like we had the request for these resources, and then this response was created, and everything gets logged. So we could do something similar to that by just using or putting this type of logging into a dedicated logging filter. In that case, as said, however, we need to log general things, so we cannot log action specific things. Cool. Now, this being said, I guess that's mostly what I wanted to show you, because if you can take a look, and we can even just also remove this unnecessary using statements, and then everything should be actually good to go for completing the pull request, because the entire video came from this idea that, okay, you received this as a pull request that you would have to review. And if we compare to actually what we had previously, when we had a lot of lines of code, right now we have extracted different parts of this action or of the controller and different other parts of the application. And our controller is right now very clean. It's just maps the forecast request to the weather forecast as my entity. It then uses an extension method to get the value of a certain header. It creates a command. It sends the command to the mediator. Well, we do some logging here that's very specific for this action, and then we return the result. And everything other than these really very clear steps and actions, we have moved into different places, like the base controller, like filters, and extension methods. And to just summarize a little bit what we have covered so far, once again, this video is not intended actually to take as a best practice that, hey, in a controller, I should do logging and log information. No, I just wanted to kind of like create a general setup that is similar in a lot of ASP.NET Core applications, in a lot of controllers, and in a lot of controller actions. And looking through GitHub repositories or even at work, I have come to the conclusion that a lot of such actions or controllers, they are using AutoMapper, they are using Mediator, they are using logging, they are doing model validation, and we have placed everything actually in the controller, just like I have seen it in a lot of scenarios. And then that was kind of like the purpose, is to find a very general structure that could apply to most cases. And then the main scope of this video was actually to walk you through a thought process that I will, or that I'd propose you right now, to actually go through whenever you work on a new controller or on a controller action. And this thought process would always actually go and say, okay, do I have a working action and a working controller? Yes. Cool. Then let me check. Can I move anything into a base controller? Can I move anything into filters? Can I move anything into extension methods? And of course, if the answer is yes, then I should go ahead and do that, because it will keep my controller and my controller action much more readable, cleaner, and well, easier to understand for anybody that kind of like looks into this code. If not, so if we don't, if you are not able to actually move things to the base controller, if you are not able to move things to extension methods, or if you are not able to move things into filters, then it means that our controller is already clean enough, and I guess it should be good to go. Once again, I wanted to really thank you very much for watching this video and for tuning in. I hope you found out, or I hope that the information shared here was kind of like useful for you. And if you think that it might be useful for others, don't be shy and feel free to share this content with your friends, with your peers, at work, wherever you see fit. Also, subscribe to the CodeWrinkles channel if you didn't do that already. Hit the thumbs up button, and if you have any questions or just want to say something, head over to the comment section and just leave me a comment, and I would be more than happy to get into a discussion with you. This being said, once again, thank you very much for watching, and until the next time, I wish you the very best.